Welcome to solverfy.
So for this one, for our part A, we have the molality. So our molality is 0.02256. This is the molality of your glycerol. And for part B, we have the mole fraction of glycerol, that is 4.063 times 10 raised to the power of -4. And for part C, the concentration of the glycerol solution in percent by mass would be equal to 0.2074%. Now for this one, for our part A, we have the given concentration, which is from the question, that is 2.350 times 10 raised to the power of -2. So to get the mole of glycerol, so we have 2.350 times 10 raised to the power of -2 times 1.00 liters. So the mole of your glycerol will be equal to 2.3 rather. So we have 2.23 or 2.350 times 10 raised to the power of -2 mole. And the volume of water is basically 999. So volume of water is 999.0 ml. So to get the mass of your water, we need to multiply 999.0 ml times 0.9982. This is the density. So cancel out the ml. So the mass of our water will be equal to 997.2 grams. And we need to convert this one into kilogram, and this would be equal to 0.9972 kilogram. Now to get the molality of your glycerol, we were gonna use 2.350 times 10 raised to the power of -2 mole divided by 0.9972 kilogram. So we will just divide 2.350 times 10 raised to the power of -2 divided by 0.9972. So the mole of your glycerol will be equal to 0.02356. Now in our part B, we have the mass of our water. So mass of our water, that is 997.2. And to get the moles of your water, we have 997.2 grams divided by 18.0. This is the molar mass. So we have equal to 55.53 mole. And to get the total moles, so we have the total moles. So we have 2.350 times 10 raised to the power of -2 mole plus 55.53 mole. So 2.350 times 10 raised to the power of -2 plus 55.53. Our mole will be equal to 55.5535 mole. And to get the mole fraction, so we just need to divide 2.350 times 10 raised to the power of -2 and divided by 55.5535 mole. So we just need to divide 2.350 times 10 raised to the power of -2, and that would be equal to 4.230 times 10 raised to the power of -4.